Okay, so let's learn 10.3. We want to multiply and divide Rooty thingies. And maybe let's give ourselves one example to start with. Okay. How would I multiply 3 root 7 times 4 root 2?
Turn the outside numbers together and the inside.
That seems like a great idea, right? All this stuff is multiplied together, right? I've got 3 times root 7 times 4 times root 2. Multiplication doesn't really care about the order, right? So I could rearrange this into 3 times 4 times root 7 times root 2.
Of course you
Seems
can.
stupid easy.
Yeah. Seems really stupid to me.
Okay, good. This should seem stupid easy. What's 3 times 4?
12.
Okay. And then what are you going to do with this other business?
Multiply.
And get what?
Square root of 14.
The square root of 14? Cool. What rule did you use to do that?
The multiplication.
Yeah, you use that thing about multiplying square roots, right? You guys cool with this? This is done. Awesome. Easy peasy.
What's the
That's
catch?
for real?
Yeah.
No.
Some of these are really easy.
Just wait.
They get just a touch more complicated when there's a variable in it or when we have to distribute or something.
Wow.
Okay, so here's just a touch more complicated. We have the square root of 6v, and we'd like to multiply by the square root of 21v.
Wouldn't it apply like b times b squared, right?
Okay, great. So tell me what you get. Tell me a story about what you got.
Did you factor out a 3?
Oh, that's a good idea. Okay, so here I might think about 6 as 3 times 2, and 21 you would think about as
7 times 3.
3 times 7 or 7 times 3, whatever. And so, what do you get?
Well, you can factor out a 3b, right?
Oh, you're jumping a step. I'm not that smart. Okay, so how about this? This is some square root of some stuff times square root of some stuff, right? Because those are the same root, I could really combine those as one big root.
Okay.
Yeah? And then what goes underneath my one big root?
3 times 2 times 3 times 7 times 8.
So there's a 3 times 2 times a 3 times 7 times a v, right? All of this business under here.
Oh.
Then what am I looking for to get stuff out from underneath the square root?
Common factors.
Yeah, I'm looking for pairs, right? You guys see pairs?
3 and b, square root of 14.
Yeah, there's a pair of 3's and a pair of v's, right?
Right.
So I should get a 3v,
Square root of 14.
and then there's a square root of 14 left. You guys all playing along with that? Am I worried about negatives, absolute values? Should I be?
Negative, yes.
It's not a cube.
Yeah, so this wasn't a cube, right? So I should be maybe concerned about
So plus or minus 3b.
close. I should be, right, if there was a concern, I should add an absolute value around the v, right?
Oh.
You guys see
If
that?
it was a negative, that makes sense.
Oh, yeah.
Why am I not doing that right now?
There's no negative.
Why aren't negatives allowed in here? Yeah, because up here, right, I wasn't allowed to put a negative in here. You see that?
Yeah.
So there's 3 things that I'd be considering, right? There's a v, there's v squared square root, and there's square root of v squared. You guys see that?
Yeah.
I should be a little bit concerned about which one of these I'm kind of playing with. This is just a v, right? This is an absolute value of v, and this is a v where negatives aren't allowed. You guys all see that? So this one's v, this one's absolute value of v, and this one's v, but v has to be bigger than 0. or equal to 0. You guys cool with that? So over here, which one of those cases am I looking at?
The middle one?
This middle step, right?
Yeah.
Is this middle step?
Yeah.
What about this step?
Is it the first step?
That's not the first step. It's not the middle one.
It's the first one.
It's not the first one, but it's not
third
the
one.
middle one. It's the last one. You guys see that? If I tried to put a negative in here, right, I would run into a problem pretty quickly. Because I'd be trying to take the square root of -6 times whatever. You see that? So I really should end this with, but v has to be bigger than or equal to 0.
So since you're technically multiplying together, like the third one is shown, is why you do that?
Yeah.
Okay.
This is really just to keep the restriction on v's alive, right? This thing didn't let negative v's into it. So when I say it's equal to something else, I really shouldn't let negative v's into that either. You guys see that? That's a function perspective, right? This function's domain doesn't include negative v's. So when I say it's equal to this function's domain shouldn't include negative v's either. That's definitely a varsity thing. If you're just playing this game and not understanding that, don't worry about it too much. What's up?
So what if you were multiplying like 3 instead of 2 like that?
Okay, so let's do another one. That's a good example.
Would it follow this cube?
Okay, so let's say we had the cube root of 6, or the square root of 6v, the square root of 21v, right? The two things we just did, and also a square root of 7v. Is cool with this? Okay, so let's see. These two guys are going to turn into what I just decided, right? So I'm going to get a 3v square root of 14, and then I've got a square root of 7 and a square root of v. You guys see that? This is a little bit different because I broke this into more pieces, and over here I broke it into fewer pieces, right?
So if you had the whole one at the
But
top
they're the
there,
same.
you couldn't put that all under one.
You certainly could.
And then you'd have 2 7s in there, right?
Sure. Do we want to do it that way? Maybe we should do it the same way, I guess.
Yeah.
Okay, let's do it the same way. So we've got 14 times 7 times b all under the square root.
Would you just bust out the 14 and then 2 7?
Yeah.
Yeah, that's
So
what I-
14 is 2 times 7. So I can get a 7 out of this thing. So I've got 3v times 7 times the square root of what's left in there.
2v.
There's a 2 and a v. You guys see that? Can I do any better than this?
Yeah, can you square root of 2 to get to, no.
Just
7 and
multiply the 3b and the 7.
Okay.
Oh,
That's a good idea. So I get 21v square root of 2v. Can I do any better than that?
Rearrange it.
Yeah, I could rearrange a little bit. But pretty much this is as good as it's going to get. So what if there are 3? What if there were 3? What happened when there were 3?
It's just stay the same.
Right, I had 3 under a square root. So 2 of them, right, paired up and became a regular v. The other one's just kind of left over. Another way I could write that is v to the 3 halves there, and then it'll be the square root of 2 in the one. So another thing I could write is I could write this as 21 square root of 2 v to the 3 halves.
Yeah, okay, you say so.
Right, because multiplicatively I have a whole v and then another half of one.
So if like one of those was actually, so it was like v squared would just come out as 21 v squared, the square root of 2.
Yeah, so if there was one more v in here someplace, if one of them was squared, yeah, I'd get 21 square root of 2 v squared. Because there'd be another half kicking around. You guys all see that?
No.
Yeah, I wouldn't sweat that one too much. Cool? Alright, should we try just a touch more complicated?
Yes.
Sure.
Why not?
Okay, so just a tiny bit more complicated. What if we had 4 square root of x times 3 square root of x minus 11?
Distribute.
Oh, you guys all see that? Yeah, I really should distribute, right? There's nothing new in here, right? This has got to get multiplied by both pieces. So what do you get?
Yeah,
12
square root of x
square root of x
squared.
squared minus 44 times the square root of x? Yeah, awesome. What's the square root of x squared?
X.
Should be x, right? Am I worried about signs? Should maybe be a little concerned, right? Because it's an even power. So this one should tell me that I should, what? Put an absolute value or worry about positives?
What about positive?
Yeah, this is one of the worry about positive ones. And I already have that down here, right? Negative x's aren't going to fit in this thing anyway, so I don't need to make any little note. You guys cool with that? So this is your answer, plain and simple.
Oh, you don't have to combine it.
Can you?
Not like
Yeah,
that.
x is half.
Oh, it's
Yeah,
just-
12.
Yeah, this is a plain x, those are root x's, those things don't fit together. Right, remember, they have to be pretty much the same thing. And by pretty much the same thing, I mean they have to be exactly the same thing.
If it was just 12 minus 44, then you could.
Yeah, so if we had 12 root x minus 44 root x, then we could combine them. Or if we had 12x minus 44x, then we could combine them. You guys cool with that?
So good.
Yet another one?
Try.
Yep.
Okay.
Fraction.
We're not going to do fractions yet. We're going to warm up a little bit first. We got root 2x plus root y times root 2x minus 5 root y. So what are you going to do with this one?
Boil it up.
Oh,
That would,
yeah. You got a foil. Why do you got a foil?
Set up that way.
Yeah, because it's set up like something you have to foil. Right, it's two binomials multiplied together. Foiling is the tool for this. So when you foil, what do you get?
Cube root, or sorry, square, 4x squared. No, square root of 4x squared.
Isn't it this, isn't it
No.
2x?
2x
Okay,
squared.
so word to the wise, do not try to evaluate any of this crap in your head. Just write down which piece you mean to multiply by which piece. So
Square
for
root of 2x.
firsts, I mean square root of 2x times
Square root of 2x.
square root of 2x. Okay, and then for, how do you spell foil again?
and then
O?
And then it's the.
O is
Outer.
outers. So I get a
2x.
Square root of 2x
square root of 2x
times negative 5 square root of y.
times negative 5 square root of y. And this symbol should be a,
Multiply.
Multiply.
Add.
you add the things you're foiling, right? And then how about the i's? Inners?
And then you got square root of y times square root of 2x.
Okay, square root of y times square root of 2x. And then we've got last, our plus
Square root y.
Square root of y times negative 5 square root of y. Oops. Said it, didn't write it. Negative 5 square root of y. So then what?
And we do each one.
Yeah, now there's 4 little problems, right? So you do each one. So what do you get in this first bit? 2x. Awesome. How about in this next bit? Good, there's a negative 5
Square root of 2xy.
square root 2xy. Wonderful.
Plus square root of 2xy minus 5 square root of y squared.
Plus square root of 2xy minus 5y.
What? 5.
Right? And then,
Combine like terms.
awesome. There's some like terms here and here. So how many of those are there?
Negative 4.
Negative 4. So I got 2x minus 4. What are the like terms?
2x square root of 2xy.
Square root of 2xy. And then there's a minus 5y. Very nice, good. Okay, do I need to worry about signage? Probably should, right? So up here, which things weren't allowed to be negative? Yeah, neither x nor y could be negative, right? Down here, x times y has to be positive, right? Does that mean they both have to be positive? No, they could both be negative, right? Okay, so I've got a restriction, and I better write it down. Should be x has to be bigger than or equal to 0, and y has to be bigger than or equal to 0.
Couldn't they both be negatives?
Yeah, that's exactly why I'm having to write this down. Because if they were both negative up here, things would be broken.
Okay.
But down here, both negative would work.
Okay.
You guys see that?
So that whole thing would be the answer.
Yeah, so my whole answer is this guy.
Where'd you get 4?
Where did I get this for?
5.
So there's
There's a 1 in front of that 2.
sheep here and here, right? And you've got 5 anti-sheep and 1 more shows up, leaves you with 4 anti-sheep.
When you do the AC method, you get to the end, you got 2xy, 2xy, those grouped together, and then you try to put those 2 outside pieces together. So it becomes 1.
Did that help, or was that asinine?
I'm just going with the flow.
This is really just,
Good grade.
there's minus 5 of whatever these are, right? And then there's 1 more. So in the end, there's minus 4 of them. Cool? Should we do an easy division one?
Yeah.
Yeah.
Yeah? Okay. All right, and primarily on division here, there's one little trick I want to teach you. Okay? There's really pretty much one trick I care about here. The other stuff in 10.3 should be in 10.5. Okay? And we already covered 10.5. So this is the one trick I want you to know about division, which is when the bottoms are messy looking, right? Everybody agree the bottom of this is messy looking? Okay, I need to multiply top and bottom by something to make the bottom nice looking and leave the top the mess.
Square root of 5.
Okay, so I might try. Okay, I like where you're at. Multiply both top and bottom by 0 is great, except that that leaves you dividing by 0.
Yeah.
It was a really good idea though. So let's multiply by, if I try root 5 over root 5, why would I do that at all? Like, why is that a good idea?
get rid of the 5 on the bottom.
Yeah, because that'll make this, instead of a root 5, it'll make it a, yeah, a regular 5, right? But why is this not quite the right thing?
So that's not getting rid of the whole bottom.
Yeah, I'll get a root 5 up top. I'm willing to pay that price.
But the 3.
But there's going to be a root 5 on the 3, and I'm not willing to pay that price.
You want the whole bottom?
So, what else? What could I do that would be
Minus
better?
3.
Minus 3?
Yeah, minus
So then on the bottom I'd have
1.
5 and
Negative 3.
positive 9.
Yeah.
But what'd you lose?
negative sign.
You lost the square root.
What? I lost all of you, didn't I? Okay.
9's on the bottom.
So if I try this, let's try it.
Okay.
Okay.
You didn't say it was good truth. You just said it was true.
No.
No, I'm just kidding.
What?
You missed the spot.
Sorry, my bad. Is everybody comfortable with the erasing the board now?
No, there's still spots that are missing up there.
Missed the spot.
Shut up. All right. So this is not quite the trick I want. The reason for that is on the top I'm going to get 12, and then there will be this stuff, right? Root 5 minus 3. This was the price I was willing to pay. But on the bottom, I have 2 things multiplied by 2 things, so what do I have to do? I've got a FOIL, right?
Is that what we're supposed to do?
Yeah, this isn't going to be a good idea. It's almost a good idea. So when I FOIL, right, I'll get root 5, root 5. That's 5. I'm good with that piece. Then how about your outsides?
Minus 3 root 5.
Minus 3 root 5. And then from the insides, minus 3 root 5.
Plus 9.
And then on the outside, or sorry, the last, you get plus 9. So this piece I'm happy with, and this piece I'm happy with, but crap. You guys see that? So,
This made it more complicated.
yeah, this made it worse, right? Not better? What can I multiply by to make it better?
Nothing.
Negative 5.
Let me look at this. This is something squared, and that's something squared, right? You guys see that? If I wanted these middle terms to not be here,
5 minus squared altogether.
Oh, root 5 plus 3.
yes. You guys see what you saw? Why? Why would you pick root 5 plus 3?
One's gonna be negative, one's gonna be positive.
One's going to be negative, one's going to be positive. They're going to cancel.
So the top one would still be negative 3.
Do you guys see that this thing? No, this will have to be a plus too.
Yeah.
I'm forced to do that, right? If I'm going to multiply the bottom by something,
You have to do the exact same.
you got to do the same thing to the top. What was this? You guys see that? What happened on the bottom there? You have a word for that. Yeah, that's difference of squares. Because this isn't going to be a plus, right?
Yeah, it's gonna be negative.
It's going to be negative. Right? If I wrote down all the pieces here, in the middle, I'd have my root 5, and then I'd have my
3 minus root 5, and then 3.
outside term is 3 root 5, insides are minus 3 root 5, and then my
Cancel
last
each other
is,
out, yeah.
so these guys will cancel, and I'll be left with something much more convenient. In this case, a
5 minus 9.
12 times root 5 plus 3 over, what's 5 minus 9? What's 5 minus 9? Negative 4. You guys see that? Sure. The trick I'm concerned with is this thing, guys. The relationship between this piece, my root 5 minus 3, and this piece, my root 5 plus 3, that's the trick I want you to have. Okay, see that? So think about them as difference of squares factors. These actually have a name. We use them so often. These are called conjugates.
Oh, that's right, I forgot that.
That's something we'll talk about a lot more when we do imaginary numbers in 7.5 at the end of the class. You guys okay with this?
Yeah.
You want to try a few?
Yeah.
Yeah, let's try some. Yeah. Whoops. So if we want to cancel here, we can cancel, in fact, a 4, right? Okay, so what am I going to be left with on top?
-4 times
Negative
-6.
Negative 3 times the square root of 5 plus 3. And then I can distribute this out because, I don't know. Because I've been trained like a little monkey to distribute things. Okay, so I got this. Cool. Which is actually substantially better, right, than the thing I started with? Yeah. So the conjugates are really the thing I want you to take away from this. When you're multiplying, or when you're dividing, right, number by messiness, maybe think about this conjugate idea. It helps a lot of the time.